parallel and perpendicular axis theorem. Firstly, we will discuss about parallel axis theorem along with the examples, and after that we will discuss about perpendicular axis theorem. So according to parallel axis theorem, the moment of inertia of any rigid body about any axis parallel to the axis passing through the centroidal axis, that is the axis passing through the center and perpendicular to the plane, equals the sum of moment of inertia along the centroidal axis and the product of mass and square of distance between the axes. In order to explain perpendicular axis theorem, let us consider a rigid body, and let us consider this is the centroidal axis of this rigid body. That the moment of inertia of the centroidal axis be denoted by IC, and we are required to find the moment of inertia of this given axis which is parallel to the centroidal axis. Let us consider the moment of inertia of this given axis be I. Let the mass of the rigid body be m, and the distance between the respective axis, that is the centroidal axis and this given axis bx. According to the definition of moment of inertia, or according to the definition of parallel axis theorem, the moment of inertia along this given axis I, it will be equal to the moment of inertia of the centroidal axis, that is IC, plus the mass of the body and the square of distance between the axis, that is x square. So I will be equal to IC plus mx square. Let us take some illustrations using parallel axis theorem. Let us consider this rod having mass m and length L. Let this be the centroidal axis of this given rod. We are required to find the moment of inertia of the rod along this given axis. As we all know, the moment of inertia of the centroidal axis of any given rod is equal to 1 upon 12 ml square. Let I be the moment of inertia of this given axis. According to parallel axis theorem, we all know that I will be equal to IC plus mx square, where x is the distance between both the axes. So as IC is equal to 1 upon 12 ml square, so I will be equal to 1 upon 12 ml square plus m. The distance between the centroidal axis and this given axis is easily seen to be equal to L by 2. So it will be equal to L by 2 whole square. It will come out to be equal to 1 upon 12 ml square plus 1 upon 4 ml square. So 1 upon 4 ml square is taken to be common. 1 upon 3 plus 1. On solving, we get the moment of inertia along the axis passing through the tangent and parallel to the centroidal axis is equal to 1 upon 3 ml square. We can take another example. Let us consider this ring, and the moment of inertia of the ring along the centroidal axis is given to be mr square, where r is the radius of the ring. We are required to find the moment of inertia along the axis passing through the tangent and parallel to the centroidal axis. Applying parallel axis theorem, we can say the moment of inertia along the given axis will be equal to the moment of inertia along the centroidal axis. This is the centroidal axis, and mass of the ring and square of distance between the axis, which is again the radius, that is r square. So I will be equal to mr square plus again mr square, which will come out to be equal to 2 mr square. So the moment of inertia of a ring along the tangent and parallel to the centroidal axis can be given to be equal to 2 mr square. Similarly, we can calculate the moment of inertia of any geometrical figure such as disc, sphere, etc. Now let us know perpendicular axis theorem. Before knowing the statement of perpendicular axis theorem, the first thing which should be kept into mind is perpendicular axis theorem is only valid for plane laminar bodies. Basically, plane laminar bodies means two-dimensional bodies having no thickness at all. Now let's see the statement of perpendicular axis theorem. According to perpendicular axis theorem, the moment of inertia of any plane laminar along any axis perpendicular to the two given axes equals the sum of moment of inertia of the perpendicular axis. Let us consider a plane laminar body. Let Ix, Iy and Iz be the moment of inertia of the respective axis of this plane laminar body. Applying perpendicular axis theorem, we can say the moment of inertia along z axis, that is Iz, will be equal to the sum of the moment of inertia along the x-axis and that along the y-axis. Similarly, we can say the moment of inertia along y-axis, that is Iy, will be equal to Ix plus Iz, and that along x-axis, that is Ix, to be equal to Iy plus Iz. We are not going to do any algebraic, or we are not going to use any algebraic method. Just the moment of inertia along any perpendicular axis will be the sum of the moment of inertia along the two given axes. We can take some examples. Let us consider a ring. The moment of inertia of the ring along the centroidal axis IC is given to be equal to mr square. We are required to calculate the moment of inertia along the diameter. Let us consider these two diameters and let the moment of inertia along both the diameter, which will be equal, that will be equal to ID. Applying perpendicular axis theorem, we can say the moment of inertia IC will be equal to the sum of the moment of inertia along the different axes, that will be equal to ID plus ID. So IC will be equal to 2ID. So ID will be equal to IC upon 2, which is equal to 1 upon 2 mr square. But the first point, using perpendicular axis theorem, we have to take into account that it is only valid for plane laminar bodies. Basically, we can say it is not valid for three-dimensional bodies such as a sphere, such as cone, such as hollow sphere, etc.